Hello and welcome to Mr. Thompson's Math Tutorials. Today we're going to be looking at multiplying decimals. So just like any time we're multiplying, I'm really looking at, I have three groups of 1.5. So I'm going to start by just doing a quick drawing of what that looks like. Now 1.5 is 1 and 5/10. 1 and 5/10, which is the same as 1 and 1/2. So that tells me that when I draw this out, I'm looking at three groups of 1.5. So here's my first group, here's my second group, and here's my third group. Okay, and I can see that I have one hole here, two, three holes. Here's my fourth hole right here, and then I have this 1/2 left over, which would mean that this is 4 and 1/2. But since 4 and 1/2 is the same as 4 and 5/10, this is actually equal to 4 and 5/10, which is 4.5. All right, so that's conceptually what's going on here. We're looking at groups of. Let's look at what happens here. On this one, I'm multiplying 5 and 4/10 times 2 and 5/10. Once again, if I think about it, this would be the same as 2 and 1/2. So this is 2 and 1/2 groups of 5 and 4/10. Now I'm not going to draw that out, but what I'm going to do is solve it arithmetically, and I'm going to start by doing an estimation. So I'm going to estimate this for 5 and 4/10, and I'm going to make a bit of a leap and call it 6 times 3. So that tells me on the high end, my answer should be around 18. And on the low end, I'm going to round this down to 5 times 2, which is 10. So on the high end, I should have 18. On the low end, I should have 10. My answer should be somewhere in between those two. All right, now it's important when you're doing multiplication of decimals that you start out by making sure that you don't line up your decimal. So when I do this question, 5.4, I'm going to do it with sort of a standard algorithm. My decimals do line up, but it doesn't really matter. Okay, and now I'm just going to multiply. So I have 5 times 4, which is 20, carry my 2. 5 times 5 is 20 plus, 5 times 5 is 25 plus 2 is 27. I'm putting my placeholder. 2 times 4 is 8, and 2 times 5 is 10. Okay, now I just go ahead and solve this. I've got 0. 7 plus 8 is 5. I carry my 1. 15. I carry my 1. 1 plus 2 is 3. So I get this. Now, there's a problem with this. This cannot possibly be the answer because my answer needs to be between 18 and 10. Now, what's missing is the decimal. So my decimal can either be over here, like in 1,350, over here, like in 135, over here, like in 13 and 5/10, over here, as in 1 and 35/100, or over here, as in 1,350 10,000ths, or 135 thousandths. Now, what is the most reasonable? Which one of these is between 18 and 10? Well, I can see right here, this one is actually between 18 and 10. So this will be 13.5. Now notice I didn't write the 0 after the 5. It's nothing, so I don't need to put it in. This can cause confusion sometimes, so be careful about that. I can also see that if I count the number of places, decimals, that I'm actually multiplying, there's 1 decimal that I'm multiplying in the question, 2 decimals that I'm multiplying in the question, that'll tell me the number of decimals I need in the answer. And I'm just going to skip my decimal over from the right to the left, and I can see that those match up. Now, I would prefer that you do an estimation to figure out where your decimal goes. But you can also count the number of decimal places and skip it over. Let's look at this one right here. Now, once again, 5/10 is equal to 1/2. So this is really saying that I have 1/2 of a group of 8/100ths. Now, if I think about that, half of a group of 800 would be 400, so half of a group of 800ths would be 400ths. So that's going to be my estimation, and let's see if we actually get that as an answer. So, once again, I'm going to just use a standard algorithm here. I'm going to multiply. Notice again, I don't care about my decimals lining up, and I'm simply going to multiply. So 5 times 8 is 40. I carry my 4. 5 times 0 is 0, plus 4 is 4. 5 times 0 is 0. Okay. Now, I need to place my decimal correctly. Now, I know that the answer should be 400ths, but notice that there are 3 decimal places in this question. Here's 1, 2, 3 decimal places. I skip my decimal once, twice, 3 times from the right to the left, and I end up with my estimation. So I can tell that that's a reasonable answer. All right, on this last one, we're going to start by doing an estimation. So 4.8 or 4 and 8 tenths is pretty close to 5 times 9.5 or 9 and 5 tenths is pretty close to 10. And let's see, that's my high. So on my high side, it should be about 50. On the low side, if I round this to 4 and 9, I'm going to get something close to 36. Now I'm going to try a bit of a different algorithm to solve this. I'm going to use more or less an area model. So I'm drawing out my area model here. I'm going to put my 4.8 here and my 9.5 here. I'm going to just divide this up. Okay, and then I'm going to multiply. So 4 times 9 would be 36. Let's see, 0.8 times 9 is going to give me 7.2. And 0.4 times 0.5 is going to give me 0.4. And 4 times 0.5, let's see, 4 times 0.5 would be 2. Okay, and then I just add all these together. So 36 plus 2 plus 7.2. Notice I'm lining up all my decimals. Plus 0.4. Okay, and I'm just going to solve this. Let's see, this would give me a 6 down below. Oops, I almost forgot to put my decimal there. 6 plus 2 is 8, plus 7 would be 15, and carry my 1, and 1 plus 3 would be 45. Okay, so we get 45.6, which is between my estimate, and so that seems right. But let's check it one other way. Let's do the standard algorithm and just see if that is in fact what we're getting. Okay, so 5 times 8 is 40. I carry my 4. 5 times 4 is 20, plus 4 would be 24. Put my placeholder. 9 times 8 is 72. I carry my 7. 9 times 4 is 36, plus 7 would be 43. Okay, and then I'm going to add these together and see what I get. 0 plus 0 is 0. 4 plus 2 is 6. 2 plus 3 is 5. And then the 4 gets carried down. There are 2 decimal places in my question, 2 in my answer, and I'm getting the same thing. I can tell that this is indeed the correct answer. Thank you for watching.